Hi, everyone, and welcome to today's episode of Where Does Your Journey Stem From? Hosted by myself, Dr. Karina Minardi. Today, we have a wonderful guest joining us today, Andrea, who is a graduate student at the University of Berkeley. So let's all welcome to the stage, Andrea. Hey, Andrea, how are you?
Hello, everyone. I'm very good. Thank you so much for having me.
Yeah, of course. We're excited to have you. So, Andrea is an environmental engineering PhD candidate in Dr. Ashok Gadgil's lab at the University of California, Berkeley. As part of Gadgil's lab, Andrea works on the design of technologies for the removal of chromium in groundwater and hopes to extend these technologies for the removal of other contaminants, such as uranium, found in groundwater. Andrea earned her Bachelor of Science degree in chemical engineering from the University of Connecticut. Before moving to the United States, she lived in Colombia, where she saw many communities lack access to clean air and water, food, and sanitation. As a graduate student at Gadgil's lab, she wants to use her expertise to create and improve effective, low cost technologies to help resource limited communities have access to safe drinking water. Isn't that powerful? So, again, welcome to the stage, Andrea. We are so excited to have you. And of course, our first question that we usually ask participants is tell us a little bit more about yourself beyond, your academic background. I read in the bio.
Yeah, of course. So I grew up in Bogota. That's the capital city of Colombia, with my two brothers and my parents. And we never expected that we would move to the United States. We never saw that coming. It was until I was 13 that we received the letters from the embassy. My parents had applied before I was even born, so they thought it was never going to happen. So it was quite surprising to me to realize that my whole life was going to change. But while I was in Colombia, I was still interested in the sciences. My grandfather from my mom's side, he was an electrician, and he always had really cool projects in his house. So I really like to watch that and see how he fixed pretty much everything in the house. He also had his own water reuse system. So he would collect rainwater and redirect that water towards flushing the toilets or the toilets. They had many bathrooms in their house. So I always found that interesting. My mom is a math teacher, so I always enjoyed math as well, and she made it very fun. She's a great educator. And yes, I was very interested in the sciences. I really enjoyed chemistry. I liked making something applicable. So when seeing my grandpa, I thought I wanted to be an engineer. And so when I moved to the United States, I still had that in mind. And I also had in mind the trip that I took when I was in high school that really uh, put into my mind what I should do with the skills and my interests, like how to make an impact in the world. And so in this trip, we were maybe in Earth grade. We were pretty young, and we took a trip to the Bogota River where it is born. So it's from a spring and it's very beautiful. And in this region too, um, they call it paramos, and those ecosystems are only found in South America. So they're very, very unique. It's like a tundra. And you can find really fresh water, unique vegetation. So it was a pretty unique experience. And during that trip, we saw really pure water. It was just gorgeous. We could drink from it. But then later, when we were walking, we could see some of the water being contaminated in Colombia, like in other countries too. for people that are affected, it's pretty hard to fight with big companies or do protest. A lot of them will sacrifice their life. So a lot of the people affected were just accepting it as it was. And so for me, when I was an eighth grader, I was like, oh, well, I'm good at science. I would like to do engineering. Maybe I can focus on something that has to do with cleaning water or the environment. But truly, during that trip, it did break my heart to see how such a beautiful ecosystem was being destroyed by these companies that were trying to extract precious materials from these areas. So that was like my main motivation when I was in 8th grade. And then finishing high school in the United States, I was still interested in sciences, learned English. I didn't speak English. So that was quite frustrating. And then, yes, after that, as you read, I did my undergrad in chemical engineering, having my interests in mind. I did some research. That was the other thing. I'd never thought I would be doing research. I thought I would be working as a chemical engineer in a chemical plant, trying to process their wastewater to make it cleaner, or working for a consulting firm, trying to remediate sites. So that's what I thought I was going to do during my undergrad. But then things changed. I met people that were in programs like McNair, Scholar Program, LSAMP, and that's how I started getting involved in research. And now here I am in California. Why California? Weather was a big factor, but also the lab that I'm working in, because they also focus on having science and engineering as tools to improve society.
No, I really like that story. And I think that that's a powerful amalgamation of the people who have surrounded you in your life and how they have contributed to your love of STEM. And I say STEM because it's not only sciences, but it's also engineering and it's also mathematics from your mom. So that's really, really powerful. And a lot of the stories that we hear, particularly on this podcast, are those students have been impacted by either a teacher or a personal friend or even a family member. And so that's really cool that your grandpa did water reuse. I mean, that's just fabulous. And then I think your one experience, around the Bogota River, I think is really, really crucial. Can you tell me a little bit about the contamination and sort of what was happening in the region? Can you explain a little bit more about that?
Sure. So in a lot of paramos, there is I'm forgetting the word of that. Mining. Sorry. So in that region, there is a lot of mining, and in other paramos, there is oil extraction. Thankfully, the government has been trying to protect these really fragile and unique ecosystems. But where I went, there was a lot of trash in some areas. So people were just going there and trashing the paramo. So yeah, a lot of mismanagement of waste. And some mining was starting to occur when we went to visit. I don't know how it's looking like right now. I would love to go back and check what's going on. But yeah, back then it was like probably 2010, 2011. Yeah, that was the situation in that area. A lot of waste being thrown nearby, some mining, and no oil extraction, but mining for sure.
Yeah, I was just curious how it related, if it was a byproduct of the actual contamination or was it a human creation of contamination? So it sounds like it was a bit of both. Plus, when you think about oil extraction, I mean, that creates a whole bunch of contamination as well. And then circling back to your graduate studies for heavy metals, I was just curious about that. But let's fast forward then, because you then came to the United States, was educated, you then went to the University of Connecticut, and you talked a little bit about chemical engineering and you aspiring to being a chemical engineer. So talk a little bit about what, the research bug that essentially bit you.
Yes. So, yeah, chemical engineering is very interesting. I really enjoyed my time taking all the classes, learning mass transport, unit processes. All of that was really, really fun. The research bug bit me when I started taking research units. So in my university, they allow you to take research units instead of a class and also go towards your diploma. So I decided to give it a chance. And what I noticed is that they wanted to know the why of things. So wanted to go deeper, understanding why. Because in engineering, or at least my impression was that a lot of times you just go to a company and solve their problems and not like whatever makes them profit. But you are not allowed to always answer why. Like if something interests you, you will not have the time or resources or support to answer that and go deeper and satisfy that curiosity of understanding why. So yeah, that's when it bit me. And I never went back. I continued in research, working on, during my undergrad, I worked in a lot of projects actually. I was trying to figure out what was the right fit for me. And my first project, like research project, was on trying to model nitrogen deposition on the contiguous United States. And so it was mostly modeling, a lot of MATLAB and ArcGIS. And yes, it was a lot of coding. I really enjoyed it and was decent and good at it. So it was great, but I also did research on material sciences, like how to improve the loading of car catalysts. That was also very interesting. Um, Also, I had the chance to go to the University of Shanghai, Shanghai University, sorry, through LSAMP. And over there, we looked at a membrane for removing humic acid. So it was more water treatment, and I truly enjoyed that. And I could see the immediate impact. So, yeah, in China, there were a lot of water bodies that were contaminated, and I could see that they were very interested in trying to find ways to clean water. And the research was great. Seeing the impact was pretty immediate, was also fascinating to me. So that's when I started considering more water treatment versus modeling. Even though modeling is still important and I still do some of it, I was more interested into the wet lab side of things instead of just coding and doing modeling in a computer.
So there's two things that I really like and that I want to mention from your experiences is one, your openness to a variety of different lab, not only cultures, but also research topics. I think that is key to thinking about, you don't know if you don't like something until you actually try it and you go, this is really not for me. Or you try something and go, oh my goodness, this is exciting. I really enjoy this. And so there's that. And then the other thing is your sort of ability to say, I still want to stay in chemical engineering, but I want to see the different applications. And not only do I want to try different types of research, but also try different types of research topics that are still under the umbrella terminology.
Correct. Yeah, that's what I enjoyed a lot about chemical engineering, that it could be applied to so many different topics. Like the fundamentals are still there. Mass transport, unit processes sometimes for water treatment, yes, they're there. Kinetics. So all of that is still the same. So yes, and I would say environmental engineering sometimes feels like an application of chemical engineering, but to the environment. So
Oh yeah, for sure. Sometimes, and sometimes it's not.
yeah.
Did you go directly from undergrad into graduate school?
Yes, I did.
And why did you make the decision?
Why? Why I talked to a lot of people before making that decision, and a lot of the things that I heard were like, Andrea, if you go to industry, you're not gonna go back to academia. You're gonna enjoy the money and never go back. You should just go straight ahead and, you know, just go, because then it will be too late, like age wise and I guess money wise. Why would I go back to academia after earning money? So that I heard a lot, and also that I heard that it's very difficult to go back into the studying mindset, because at least in a lot of civil and environmental engineering programs, you need to do a master's first before continuing into the PhD. And so that first year of master's year, you're still taking classes. So it's like undergrad on steroids. That's what like they called it. So yeah, I guess I was a bit afraid of never going back to academia to get my PhD. And also I knew I really enjoyed research. So in my head I was like, why would I not take this opportunity if I know that if I'm gonna get accepted and get full funding or a good funding package, why would I say no? Like I enjoy research. Why not?
No, that's totally fair. And everyone has a different answer and a different reason. And so I was just curious about yours. I think we have had students on the podcast who did take, I know at least Rachel, for one, took at least a decade off in between of working, having kids, so it's totally possible. I think it also is, what are your career aspirations that are driving you to? I think for them in particular, they had different career aspirations when they left undergrad versus I think you quickly realized, I'm not trying to put words in your mouth, but you quickly realized I need a master's and a PhD in order to get to that next level for what I want to actually do. Which is also totally fair. So if you realize that and it aligns with your career aspirations, for sure, go and do it. So that's fabulous. So talk to us a little bit about. I mean, you already talked obviously about your background in water treatment, waste management. So talk to us. How did you actually get to Dr. Gadgil's lab?
Yes. So the summer before my senior year, I took a lot of time to research different labs in different universities. And I did notice that, well, I knew I wanted to do research on water, but that could also impact society or communities. And a lot of them were in air quality, which is also very, very interesting. And I already had some experience in the air quality. So I started looking professors either air quality or water quality. And then when I was looking at Berkeley, so first I came across Berkeley because when I Googled best universities in environmental engineering, Berkeley was one of the ones that popped up. And when I started looking at the different professors, Professor Ashok was one of the few that looked at science and engineering applied, like applied projects and problems, and well, projects that will make a positive impact in communities. And so that's why I came here and was very, very interested in his research. And another thing that I found quite interesting is that he's actually a physicist. He's not a chemical engineer, he's not an environmental engineer, and he was also a scientist at Lawrence Berkeley National Lab. So for me, it was like, wow, he's very invested into this. He really wants to change things for these communities, make an impact with science and engineering. And so, yes, I was super interested in his work. I read some of his papers, and they still explore science. So they were not only engineering, but they were trying to understand why the system they were using behaved a certain way. And so, yeah, that's how I ended up here. And also, when I came in person, we had a conversation, and I thought he was a good academic, but also a good person. And so, yeah, we clicked at that moment, and also met other lab mates. We got along. One thing that I noticed too is that a lot of them were not from the US. Like a lot of us were from other parts of the world. Only, I think, just a couple were from the US. But yeah, that was very interesting. We all got along. We cared about these communities, some of them from a personal level. There was a graduate student that was from India, and he was from some of the villages that they lack access to safe drinking water. So yeah, that's how I came across Ashok and why I joined his lab.
Very fascinating and cool. And everyone has their own reasons. And I'm curious again, like the title of this podcast is where does your journey stem from? And so it's again, like, how do you choose? Where did you pick? What were the factors that you chose or decided upon? So let's actually delve right in to your research. So talk to us a little bit about, chromium contamination in groundwater. How do you identify it? What is your hypotheses? Where are you taking samples? Tell us everything.
So chromium contamination comes from both industry and geogenic reasons. Chromium has two oxidation states, chromium-3, chromium-6. Chromium-6 is the contaminant of interest. Chromium-3 is an essential micronutrient. So if you take multivitamins, you will see chromium, and that is chromium-3, not chromium-6. The big difference is that chromium-6 is highly mobile, and it's an oxyanion, so it has a negative charge. Soil has a negative charge too, so they repel. That's what makes hexane chromium so mobile. Trivalent chromium mostly exists as a solid, so it's usually in the solid form, so it precipitates. In the lab, we have done an electrocoagulation for quite a while, and this is an electrochemical technique. So it's very simple, and that's the point, so that people in these communities are able to replicate it and have it. So in this system, there is two iron plates parallel to each other, and then you attach them to a power source. So in the lab, we have a power supply, And the good thing about this system is that you can decide how much iron to put in the system by just changing the current. And also you can decide how fast you want to put the iron in the system. So it's a very versatile technology, very cost effective, which is a number one priority for us, the cost. There is great research out there, but they use a lot of precious metals that are expensive, so it's very hard to actually take it outside of the laboratory. So in the Gadgil lab, they have used iron electrocoagulation for a while for the removal of arsenic, which is another groundwater contaminant. A lot of communities have been affected by arsenic. The problem with arsenic, same with chromium, is that when it's in the water, you cannot see it, you cannot taste it, you cannot smell it. So it's hard for people to know that they have these contaminants. So chromium can be found in California, again, geogenic reasons. So the minerals in the aquifer have chromium. Hexyl and chromium is used as a rust inhibitor. So it's widely used in plants where they want the metal to not get rusty or rusted. And also, hexyl and chromium is used for leather tanning. So a lot of these companies will use hexyl and chromium. So those are the two primary uses in industry. I don't know if you have watched Erin Brockovich.
I have, yes.
Yes, so that's a good intro into chromium. I don't know if you remember, but PG&E tries to convince them that chromium is good and all of that, but they never told them the difference between chromium 3 and chromium 6. So it's very, very important. So in the laboratory, we use iron electrocoagulation to also remove chromium. That's what I started studying. Like, yeah, for arsenic, it works great. There are pilot plants in India, so we know it is a scalable technology. But now the challenge is to have this technology in the United States. And since it's a different context, there are a lot of things that need to be changed. So number one, we need to address the operating cost problem. So in India, operating costs are pretty low. So manual labor is not a problem. So what happens in iron electrocoagulation is that the plates develop a layer that needs to be removed. So in India, they do it by hand. In the United States, that's going to be very expensive. So finding a way to make the reactor not develop this layer while it's operating, or how to remove the layer without having people taking out the plates and scrapping them. So that's one issue. Also, automation. Automation is very important anywhere, especially in the United States. Again, labor costs are pretty high. And something that was explained to me by a technician that I had no idea was that in real life, when there is a water treatment, once you add a piece of technology, the operators need to be trained. And so there are different levels of operators. And the more technology you have, the more education they need, and the more expensive they become. So that's something I didn't know until I got into grad school. So automation is very, very important when designing these technologies. And yes, so the other thing too is to investigate how the removal occurs inside the reactor. So in the reactor, we do create iron 2 ions, and these ions are very good reductants. So iron 2 is going to reduce chromium 6 into chromium 3, and then iron 2 becomes iron 3. and that's how you can remove chromium-6 from the groundwater using iron electrocoagulation. So the chromium-6 becomes chromium-3. Chromium-3 mostly exists as a solid, so it creates a precipitate with iron, so there is co-precipitation. And these precipitates, then you can easily remove them through settling and just settling and separation. So the technology is quite simple, but then the challenge is how to optimize it, how to improve it, understand how different water conditions affect the removal mechanism of chromium inside. Also trying to figure out like the optimum current, the optimum iron needed, having a safety limit. Also thinking about the waste. Where does that iron go? The iron sludge with the chromium, where does it go? Is it stable enough? Is the chromium-6 going to reoxidize again in the environment? So all of that is what I'm investigating in my research.
So given all of those variables and given all of the different varying conditions by which you can then alter to then look at what is the optimum, most efficient system, what keeps you up at night regarding the system?
A lot of it keeps me up at night. So currently, the reactor, so we're trying to come up with a new reactor design as well. So that's when chemical engineering comes in handy. Before and traditionally, iron electrocoagulation is operated in batch mode. So just a big tank, dose the iron, and then move the fluid. So that's how it's usually operated. What I'm trying to do is to have a plug flow reactor. So it's more like a tube. And with this tube, you can speed up the process. You can treat more water continuously. Those are the perks. The challenges is that there is a lot of precipitates inside and clogging the system earlier than it should. And it's a lot of design issues, like how to go from batch to continuous flow in a way that the reactor will actually last a long time is quite challenging. But yes, I've tried different designs. I have arrived to some optimal ones. I'm still testing them. And then, yes, testing the different water conditions is going to be another challenge. But that's when also some modeling comes in handy, because you can model some of these systems. So you just need to test some points. Like you don't have to test all of the pH values. You just need to test like the two ends and one in the middle and see if it fits the model. And then if people have different pH conditions or dissolved oxygen conditions or initial chromium conditions, then they can look at the model and see if it will be a good technology for them.
So Andrea, the last question that I usually ask guests is, if you were to reflect on your career and think about yourself about 10 years ago, what words of wisdom would you have imparted on yourself?
Don't be afraid of trying new things. I think that's something that it's very important for young people to try what's out there, what piques their interest. Also, not be afraid of reaching out to people. A lot of times I did find myself like wanting to reach out to someone, but then feeling super nervous because, especially professors, because I was intimidated. I didn't know exactly what to say. So just reach out. Professors love talking about the research in their life. and not just learn from them too. They're humans. So that's another thing that my mom tells me and reminds me still to this date. We're all human. So it's not like they're aliens or they have superpowers. Um, we're all human. We're here doing our best and trying our best. So do not be afraid to reach out to others. Also, finding resources, you will be surprised. There are a lot of resources out there. Ask, um, write that essay for that scholarship. Just do it. Um, another thing. Well, one thing I will say is that focusing on academia is that um, like thinking about finances is really important. When I was young, I didn't think too much about it. And then later on, I realized that yes, finances are very, very important. I took that for granted. Um, in undergrad, I was in like I had scholarships, but I was living with my parents and I was saving some money. And for grad school, like I'm away, also in the Bay Area, finances can be very important and can be something really stressful on top of worrying about research. So just be mindful of that. Um, and I think that that will be it. I think it's very important to have good people around you. Connections really matter, your friends and your family.
Yeah, support system for sure. And I love your
Exactly.
emphasis on finances. I think grad school is hard enough. Grad school is hard enough if you're a poor, starving grad student. Um, you know, you can't do research if you don't live, right? Yeah.
Exactly.
And if you live in some of the most expensive parts of the country, SF being one of them, you got to think about that. So, and with that,
Yeah.
Andrea, thank you so much for your time. And such a pleasure to have you on the episode today. And to our listeners, thank you again. And remember to always ask yourself, where does your journey stem from? Bye, everyone.